Today we're on 7.5. We're learning about factoring binomials. So I know I've got this when I can factor the difference of two squares and two cubes. The vocabulary is a difference of two squares, the difference of two cubes, and the sum of two cubes. The binomial x squared minus 9 is called the difference of squares. We've done the difference of squares before. A little bit. So a squared minus b squared equals a plus b times a minus b. Factor each difference of squares. All right, so I'm going to do the first one. So what times what is x squared? X times x. What times what is 16? 4 times 4. One of these has to be a plus and one has to be a minus. All right, let's do b together. So we've got what times what is 9x squared, 3x and 3x. What times what is 4, 2 and 2. One needs to be a plus, one needs to be a minus. All right, you try C. And there are our answers. 2a, I do factor x to the 8th minus x to the 6th. So remember when we multiply, we add our exponents. So that would be x to the 8th, right? So if I am factoring this as a difference of squares, x to the 8th is x to the 4th times x to the 4th, and y to the 6th is y cubed times y cubed, and I need different signs. To b, we can do this one together. So what times what is x to the 4th? X squared and x squared. What times what is 81? 9 and 9. I need a plus and a minus. The thing is, this one is also a difference of squares. This is not, it's a sum of squares. That cannot be factored because it's prime, but this can, so, because it's a difference of squares. Okay, so what times what is x squared? X times x. What times what is 9? 3 and 3, and I need a plus and I need a minus. And that is my final answer. You can only factor a difference of squares, not a sum of squares. So you go ahead and try this one. I hope you caught that. So the first step in any factoring problem is to factor out the GCF. So that was a 4 first, and then you would have a difference of squares. Although the sum of two squares usually cannot be factored, the sum of two cubes, as well as the difference of two cubes, can be factored as follows. So please pause and write those two things down. You're going to need it. Example 3a, factor. So I'm going to do this one. So this is a sum of two cubes, okay? So I'm kind of giving you the formula right here. So the cube root of x cubed is x. The cubed root of 1 is 1. Now I'm going to use this to do the rest of the formula, okay? So you'll notice that right here, I basically just square that, so x squared. In the last term, I square this number, so 1 squared is still 1. In the middle, I'm going to multiply these two things together. So x times 1 would be 1x, and change the sign. So negative x. So again, let's go over that one more time, okay? So do you do the cube root of everything first? Then the first term is squared. The last term is squared. The middle term is this times this, and change the sign. Okay, 3b. All right, can you take out anything? Yes, you can. You always need to factor out the greatest common factor, which would be y cubed. So when I do that, if I factor out a y cubed, I'm left with 64 minus x cubed. So I'm just going to leave that y cube out to the side. What is the cube root of 64? 4. The cube root of x cubed is x. Now let's fill in the second parentheses. So 4 squared is 16. Negative x squared is a positive x squared. And then 4 times negative x is negative 4x. Change the sign, and I get 4x. So that is my final answer. All right, you try this one. There you go. All right, here's some extra practice. Go ahead and pause. All right, the only one that I want to show you right now is this first one, okay? Because it's a fraction, we didn't do anything. H is the same way. All right, so what times what would give me 64? 8. What times what gives me 9? 3. What times what gives me 25? 5. What times what gives me A? A. And then you do the same thing over here, and one needs to be a plus and one needs to be a minus. So that's how you would do that. You do it numerator by itself, denominator by itself, and then so on. Okay, so fractions are not that scary. You just have to do them one thing at a time. And then your final answers, go ahead and pause it. Check your answers. Ask me if you need any help. So I know I've got this when I can factor the difference of 2 squares and 2 cubes. Do you really understand? Describe the factors of the difference of 2 squares, then give me an example that illustrates your description. So one factor is the sum of the 2 squares of the terms, and the other is the difference of 2 roots of the terms. Describe the factors of the sum of 2 cubes, then give an example that illustrates your description. Okay, so one factor is the binomial, that is the sum of the cube roots of the terms, so that will be the beginning. The other factor is a trinomial whose first term is a square of the first cube root, whose last term is the square of the second cube root, and whose middle term is the opposite of the product of the cube roots.